this episode of Voice of the Sea, we're in the Watershed Forests of Oʻahu, Maui, and Hawaii. We talk to hydrologists and ecological experts working to conserve and reestablish native plants and animals in these forests, in an effort to not only preserve the ʻaina, but also to recharge the underground aquifers that feed the Hawaiian Islands with fresh water. We start off with Ulalia Woodside from the Nature Conservancy in Waikamoi Preserve on Maui.
We're standing here in the uplands of Maui on the slopes of Haleakala at Waikamoi. Waikamoi is the heart. It is the poʻowai. It's the fountainhead of the watershed for Maui. And these lands that we are standing in are lands that are cared for and managed by the Nature Conservancy. They are lands that we work in partnership with the landowners of Haleakala Ranch and Alexander and Baldwin to care for this poʻowai, this source of water for the island of Maui. We're standing here in a predominantly native plant, native understory, ferns and shrubs and canopy. And that makeup of native forests, we've learned through research over the years, is much more efficient, sometimes 50% more efficient at harnessing this fog and cloud moisture that we see. We can see the moisture being trapped on the leaves there, droplets of water. All of these little leaf surfaces serve the function of capturing this moisture. And then when we look at the bark, we see that the bark is kind of gnarly and there's lichens and there's growth on it that allows all those little droplets of water to sort of filter down the plant, and it filters down into the soil and down into our aquifer, which then is that groundwater that we are able to drink. The science has helped us understand that the condition, the health of the forest, when it has abundant native resources, when it's diverse, when you see from little shrubs, little grasses and ferns to medium shrubs and mid-level understory and canopy, when you see all of these different levels, we've come to understand that's very important. So creating that place, setting it aside, and then removing those threats, those things that endanger the plants from thriving, in order to ensure that this big sponge that we have at the top of our islands continues to produce this fresh water that we need for ourselves as residents of the islands. Our visitors get to enjoy. Other things we don't think about. So many businesses rely on fresh water. Agriculture businesses, our streams and the stream life, all of that rely on us being able to effectively take care of these places, remove those things that aren't native or natural to the space, manage them, enables us to have a forest that will continue to produce water for us into the future.
Are there any particular plants, species of plants that you think of when you think of the native rainforest, or that are particularly near and dear to you?
A species that we hear a lot about, a species that's near and dear to many of us, is the Ohia lehua, that Metrosideus polymorpha. It is the backbone, the keystone species of our native forests, and can in some places make up 80 to 90% of our native forest area. Ohi means to gather. Ohi means to collect. And the Ohia lehua trees are uniquely developed to collect so many things, and one of those is moisture out of the atmosphere. In collecting that moisture out of the atmosphere, it also creates lehu or lehua. It creates many, or it creates abundance. Ohia lehua trees are also the home for many species. Birds rely on Ohia lehua for food, nesting. We have insects that rely on Ohia lehua. A whole world. As we listen to the birds talking to us about Ohia lehua also. Whole world relies on Ohia lehua, and our rainforests certainly do rely on Ohiʻalehua as that keystone and that backbone species of our watersheds. It also is experiencing one of the more concerning threats, and that's something that's called rapid ohia death, or Ceratocystis lukuohia, or Ceratocystis huliohia. It is a fungus, it's a disease that causes the Ohiʻalehua tree to die, at times very quickly. It's known on Hawaii Island and on Kauai, and the data changes as we do more surveys, but last I had heard about 180,000+ acres on Hawaii Island have been affected by that Ceratocystis lukuohia and huliohia. Let's make sure that we aren't transporting lehua anywhere, Ohiʻalehua from one island to the other. Sometimes we don't think about it, and I've noticed, and as a hula practitioner, somebody who loves leis, I think, well, I'm not bringing the plant, or I'm not bringing the flower. I'm just bringing the liko or the buds. It's all of it, right? Let's not move or transfer any of it from one island to another island. Where the tree has a wound, where the bark is opened up, what does a wound look like on a tree, right? Something where you break off a branch, you break off a little bud, there's some type of gash in the trunk or along the roots. All of those openings, those are ways in which the Ceratocystis lukuohia and huliohia can get into the plant. So to the degree that our actions, and as we manage an area, we can ensure that there aren't any mechanisms that would cause damage to those ohia trees. One of those is ungulates, or four-legged, cloven-foot animals that move through our forests that may rub up against the tree, root or dig around the base of the tree. Those create wounds, and those can damage the Ohiʻalehua. And we're finding research demonstrating that in areas where the Ohiʻalehua trees are not exposed to that type of damage, they are much more resilient.
Next, Alison Cohan explains how the Waikamoi Preserve is actively managed to help keep out invasive species.
The Waikamoi Preserve has been around since 1983. It was established with Haleakala Ranch. It's a permanent conservation easement that we are granted. So in perpetuity, the Nature Conservancy will manage this landscape, about 9,000 acres. So we have 0 animals in the preserve. We have to work really hard to maintain that. In some areas that are susceptible to storms, we'll check those fences, once a quarter. And then if there is a storm, we'll go right out again and check those fences again and put up a fence fix right away and make sure that there weren't animals that got in during that time. We're also in the preserve doing research, rare plant monitoring, and also killing invasive weeds, unfortunately, which are a really big problem. There's over 60 species of ferns in Waikamoi. It's just incredible diversity, and so it's definitely a sought-after research site. And so we have researchers apply to do research in the preserve. So we've found out amazing things through that on spiders, bats, forest birds. We work really closely with the Forest Bird Project here. The resources are really incredible. Water, it's our life, it's our blood, it's our economy, it's everything. What is currently going on right now is a pretty cool collaborative project. The USGS and UH Manoa are working together, and they're doing some hydrological studies. If we were standing in a forest, in a monotypic coverage of Himalayan ginger, all we would hear is this bap, 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 this really loud raindrops hitting these big leaves that are not supposed to be in Hawaii, and then poof, going into the ground where there's no diverse understory, there's no mosses, there's no ferns, causing erosion, causing sedimentation, and going down into our coral reef. And we know this is happening, but we need to quantify it. And so that's what the researchers are doing with various specific species that are a problem to watershed managers. Himalayan ginger, strawberry guava, we do have some data on, and we know it's a water hog. Tropical ash, all kinds of different species in different sites throughout the state. These hydrologists are going to study how they are uptaking water and what's the infiltration rate, how is the water moving down through the soil as a result of that, and comparing it in areas that are native dominant, where you have that diverse canopy where you have shrubs and mosses and ferns and everything that's taking up that water and allowing it to slowly infiltrate rather than causing this muddy mess that ends up on our coral reefs, and it impacts our ability to even survive when you have a coral reef that's got mud all over it. A place like Waikamoi Preserve, it's so resilient. Over time, we've underestimated the resiliency of these native plants. And when you have the diverse forest structure and this canopy of ohia and koa and all these species, it's a system that's working. And we need to make sure that we support it and make sure that it continues to thrive. And it is our best chance for water and watersheds and water recharge for that continuing in light of climate change. Resiliency is the key thing. So if we give up, if we stop controlling the animals, if we stop controlling Himalayan ginger, all of a sudden things like rapid ohia death and the invasive species, they will increase. And that resiliency will make this forest not good at capturing water and recharging. And if we work hard enough, we can actually expand the native forest and expand the habitat for birds that are threatened by climate change, maybe allowing them to have a greater chance of succeeding in light of all these threats. So the resiliency of the forest and the upper watershed is really important.
The University of Hawaii's Sea Grant College program focused on Hawaii's coasts and its communities through sustainable development, safe seafood supply, sustainable coastal tourism, hazard resilience, and healthy coastal ecosystems. Hawaii's Sea Grant.
Welcome back. We're in the Kona Watershed on the west side of Hawaii with Kamehameha School's hydrologist, Kāʻeo Duarte, talking about the path of water through the forest.
You can think of a droplet of water that's hitting the ground, and those that doesn't get taken up by the trees or evaporated out, will go into the shallow soil layer, or if there's a lot of rain, flow over the surface like we see in the big, and then it would go down gradient. One rivulet will hit another rivulet, will hit another one, and before you know it, you have a stream. So you have recharge of stream by a forest. Those drops of water that are not flowing over the surface or evaporated will go deeper, so penetrate into the surface, go through the soil to the rocks, and eventually down into our groundwater aquifers. So here in Kona, due to the geology and the very porous rock, we tend not to have many streams, except in big rainfall events, you will see our streams flow. Mm-hmm. But in general, most of the water that is not either evaporated or taken up by our trees is going down into our deep groundwater aquifer, which heads to the ocean. As it heads to the ocean, you'll find a lens of fresh water floating on seawater as you get to the ocean. And then you see at the ocean sometimes, especially at low tide, you see fresh water bubbling up. That's that fresh water that is started here all the way in the forest and made its way all the way down. Sometimes that drop of water fell 100 years ago, and it may take 100 years or more before it makes it to the ocean. So sometimes you could be at the ocean drinking 100-year-old rain. And then that will manifest in how our Hawaiians here had a lot of dug wells. So you still see some, a lot of them are lost, unfortunately. You still see basically holes in the ground on the ocean that our Kona people would definitely take care of. Because remember, we had no water bottles, we had no pumps and wells, so they would take care of these, and they would have fresh water floating on salt water, and you would skim that and you could drink that and use that. So you still find some of them in Kona, North and South Kona. For places like Kona, where you have the ocean in proximity to our groundwater aquifers, leads to some really interesting and dynamic physics and chemistry and biology in the mixing of seawater and fresh water on an island environment. This recharge up here that isn't going to evaporate or be used by the trees and mix it down there will become rich with nutrients. That flowing water is picking up all the nutrients as it passes through the earth and the rocks, and will actually literally help fertilize our reefs and our offshore species too. Our freshwater discharging out into the ocean, our mouths of our streams are very abundant with small fish and animals. Around where freshwater comes out at the ocean, you find limu, and then it goes up the food chain. So that Maukamakai connection is very real. Here in a pretty good native ohia forest, tall ohia forest here in Kona, a few things to point out. One is the multi-layered nature of a native forest. Well, you'll have tall trees and canopies, and then you have mid-level trees, and you have like hapu'u and kawa'u and other kinds of trees, and then you have ferns, and then you get down to thick mosses that you can see here on the ground here. And those many different layers and dimensions play a role. If we're at exactly the same elevation as here, same rainfall and everything, but we went a mile that way, say we're in the middle of a pasture. The difference would be that rain, especially for a light rain like this that falls, on a hot Kona day, that rain, the majority would be evaporated. If there's a lot of wind, wind transports moisture. So wind will come in a very open area and basically take that moist air and transport it away. When you're in a forest like this, because of the forest itself, wind is diminished. So it could be very windy a mile that way, and then you'd be in a forest and the forest damps the wind. You've got all the shade, so the evaporation can decrease. Sometimes it's not just that the forest creates more recharge necessarily. It could be the exact same amount of recharge, but the path and the timing and delivery could be vastly different. And what I mean by that is the forest slows down at a drop of water. It takes it through a more complex path. With all these multi-layers of cooling and shading, even after the rain has gone, if you go under the ferns and you go under the moss, the dirt is still wet and moist because of all the effects of the capture of water. The complexity of the forest allows it to hold and store water so that a big rain event happens, that water is on a longer path that allows it to slowly seep into the ground versus in a big open area where it may evaporate or be shuttled off very quickly and disappear. In today's world, we're realizing how do we find balance and trying to have more mixed use agriculture mixed with forest silvopastoral type uses or more complex agriculture is really the way to go. At the same time, we want to maintain some of these environments, not just for hydrology or ecology, but for the cultural and spiritual elements of having these places. You can hear our native birds, and here just over there, there's maile, there's halapalai, there's other things that are used for dance and for medicine and so forth. So having these landscapes existing today, I believe are important to the existence of Hawaiian culture and Hawaiian people.
We are looking for a few heroes, mentors, trailblazers, innovators, a passion to change lives, spark curiosity, open hearts, and awaken minds, help students answer the question, who am I? This could be your calling, but this is no job. It's the journey of a lifetime. Be a hero. Be a teacher.
Welcome back. We're on Oʻahu at the Mānoa Cliff Trail with Suzanne Case, the chair of the State of Hawaii's Department of Land and Natural Resources, talking about the importance of forests across the islands.
This is the beginning of an exclosure area that a number of volunteers have been working on every Sunday morning for over 10 years, probably closer to 15 or 16 years.
This was all bamboo, and if you look this side, it's all native. We have carex, hibiscus, koa, ko'oko'olau, the bidens. We have ohia. We have that big hibiscus, that beautiful hibiscus. And hame. Except for the tea plants, this is pretty much all native. Ie. We do a lot of air layering. This is the kokila Kāʻeo, the native hibiscus grows into a very large tree you'll see in the area. what we've been doing is we air layer a section and that means you just cut a certain section and put sphagnum moss around it. It grows roots, and then we were able to populate it around the area. It's one of the things that grows really fast. If we take out a section of invasive forest, then we have a problem with weeds because the sunlight comes in into an open area. So the things that grow the fastest, mamaki, this hibiscus, and koa. It makes us happy. You know, a lot of people do these things for different reasons. I like to do it because it's beautiful. The Hawaiian forest is beautiful. Ukiuki, that's Dianella. These are Manoa.
This is the Manoa Cliff Trail, so it's a really important recreational area. It's a great hiking trail system. It's part of the Ulalia Trail system. And it goes along in here and circles back out to the road. Beautiful trails. We're on basically the threshold between the Waukanaka, the human realm, and the Wawakua, the realm of the gods. So we're in forest, we're in mixed native forest. We're up on top of Tantalus, and that is in the middle of the Honolulu Watershed Forest Reserve. And so this whole area, all of this area is watershed for the city of Honolulu. This is where we get our water. We're actually in an area that's, again, on that threshold between urban influences and good pristine nature. Well, what that means is that invasive species have taken over a lot of the areas, but a good native forest has tremendous amount of diversity at all levels, up at the canopy, the understory, mosses and ferns on the bottom. All of that provides a lot of texture for the clouds to rest on and to capture rain as it goes down. If you're in, say, a bamboo forest, it's a monoculture. It doesn't have that texture, and it doesn't have that absorptive capacity that those good understory trees and mosses and ferns have. 100 years ago, 150 years ago, there was extensive ranching in the lower areas of all of our islands. What happened was 100 years ago, the territorial foresters and the kingdom foresters before then said, you know what, this is bad because the streams were starting to dry up because there wasn't forest to capture the rain. They built fences that have since become the boundaries more or less for our conservation districts in Hawaii. Most of the conservation district is still good native forest because we did that 100 years ago, and those fences are gone now. We've got to redo that mosaic of fences and get the animals out that are here now. Pigs have hugely expanded their population in the last 50 years, and they dig everything up and eat the middle of ferns and kill the ferns. And we're in a bit of a race against time here because if we don't control these invasive species, the forest will degrade. So what we're trying to do is keep it from getting worse. And then we're trying to get the part that's, you know, still in pretty good shape. We're trying to improve it.
As individuals, what can we do to help protect our forests?
Pay attention to what you plant in your yard. There's a weed risk assessment you can find online that will tell you whether what you're thinking of planting in your yard is something that might escape up into the mountains and create a problem. Australian tree fern was a classic example of that. Many people have now stopped planting Australian tree fern, but it's an invasive species and it takes over, even in areas where our native tree fern, the hapu'u, will thrive. Scrub your boots, plant native plants when you can. When I go out and see really good native forest, I see ohia trees, koa trees, I see hapu'u ferns, I see a whole mix of, this is a native hibiscus here, a whole mix of things that belong in Hawaii, and they all have a Hawaii story to tell because many of them are found only in Hawaii.
Native forests will continue to provide fresh water for Hawaii as long as we protect and maintain them. Hawaii has committed to protect 30% of watershed forests by the year 2030. Mahalo for watching Voice of the Sea.
The University of Hawaii's Sea Grant College program focused on Hawaii's coasts and its communities.